All right.
All right, there we go. We have finally slain the presentation monster that always wants to mess everything up. All right. So, all right, there we go. We have finally slain the presentation monster that always wants to mess everything up. All right. So, all right, there we go. We have finally slain the presentation monster that always wants to.
That was you, right? Okay. Like you said, that's some great eye.
All right. We have finally slain Okay. Woo! All right. This reminds me of that presentation, actually, back at the 15-minute presentation, anyway. All right, so is audio working? Okay. Check one. Check 1, 2.
I think we get away from
Should never live that down, though, by the way.
Take the volume down some?
No. Philo will be able to speed at this.
Presentation monster.
A little ironic. Yeah. All right. So just to reiterate, working at NASA since 2013, web stuff, but some C++, other stuff. Been playing with Bitcoin since 2013. On the investment end of things, involved in Ethereum since 2014. And we're about to do some Ethereum smart contract work as like a hobby, a personal project with a couple other friends. Nothing large scale or anything anyone's paying us for. So, so as far as the timeline of blockchain stuff, it basically starts with Bitcoin, which was released in around January 29, 2009 by this Satoshi Nakamoto character, who we don't really know who it is. He kind of dropped off the face of the earth a couple years after releasing Bitcoin. Then, as far as when Bitcoin started to become actually useful for buying stuff, one of the first transactions was this guy Laszlo, who paid 10,000 Bitcoin for 2 pizzas in about 2010. He was on some chat forum or client, I don't know, it was like a AOL Messenger or something, and he was like, "Man, I could really use a pizza right now." And it's like, "Hey, I would pay, Bitcoin for this." And so somebody else was said, "Sure." So he sent them the Bitcoin, and they ordered a pizza for him and had it delivered to his house. Actually, 2 of them. So that's one of the first like transactions. So then you can see 3 years later, Litecoin, which is the second cryptocurrency to come out live. And then today, actually, it's more than 5,000, but
Close to 6,000.
It was close to 5,000 a couple days ago.
right this second.
Yeah. So each pizza that he bought back then, is worth more than 25 million probably per pizza right now. If he had just held on to those. So there's, if he just held on to those Bitcoin.
He's so hungry.
Yeah, he would be still hungry. So there's over 1,000 cryptocurrencies in existence right now, and in large part that explosion is because Ethereum makes it super easy to have sub cryptocurrencies. But in any case, and the value of the whole ecosystem is probably over 165 billion now, across all the value stored in all the cryptocurrencies out there. So as far as actual like high profile failures, there's really only one for Bitcoin, since it's been around for almost 8 years now, I think. There was a vulnerability in the base protocol, and a hacker was able to give themselves 184 billion Bitcoins back in 2010. So they had an emergency patch, and then deployed the patch, and then all the people running nodes on the network had to restart and use the new software, which basically rolled back that transaction. They weren't going to let him get away with 184 billion Bitcoins when the maximum that is supposed to exist is 21 million. So that was a lot. There have been other hacks, but mostly like Mt. Gox and some of the other ones have mostly just been bad security at different exchanges. People being able to steal Bitcoins, and then transaction malleability was some information in Bitcoin transactions that people thought was secure, but actually could be manipulated. So it depends who you talk to, whether that's actually a bug or not, or an actual security issue. So with Bitcoin, what is it, right? How does it work? It's similar to a lot of peer-to-peer technologies out there. You start a node, there may be like a seed kind of node to talk to find other peers, but it's you create this list of, I don't know, dozens perhaps or more of peers that you talk to, and then you broadcast any network changes across between peers. The main thing that you can do with Bitcoin is you can transfer Bitcoin to other people or other wallets that you have. It did have a scripting language kind of there at one point, but they were worried about the security of it, so they disabled most of it. So you can't really do much actual logic or like any kind of scripting on the Bitcoin network itself. You can store arbitrarily amounts of data in Bitcoin, but it's usually fairly small amounts, and it's pretty expensive. Bitcoin wallets, in case anyone was curious, are using AES 256 CVC cryptography. So it uses asymmetric? Symmetric?
Yes.
Okay.
Yes, it's symmetric. The end. There's no asymmetric flavor.
Okay. Apparently my source was wrong then. So what this gives you is you have a public wallet address that other people can send Bitcoin to, and then you have a private key that you can use to initiate the transfer of your Bitcoin to somebody else. One of the weird things about all cryptocurrencies pretty much is you can generate wallets offline, and people can send you money without your wallet ever having touched the network, because it's just a cryptographic property that you don't have to register your wallet before somebody can send money to it. So it's pretty crazy. And then they can send money to it, and you can check the balance without ever having done any transactions from your wallet to the network. It's a pretty crazy property.
Does that mean you could send money
Not from it.
literally into nothingness?
Yeah. You can send money to any random address you want without it existing. So you can throw away
How do you
money.
check that you got where you wanted it to go?
Well, you assume you had that. You really want to make sure you have the right address,
Well,
because if you don't, there's no way to recover it.
The thing is, after you check, it's too late.
Yeah.
But you can go. There are websites that let you explore what keys have what, so you can just kind of look through that.
And then part of that is all wallet balances and transactions are recorded publicly on the blockchain, so you can verify any transaction that you've done. You should be able to find the block where that happened. So when we talk about blockchain, what we're usually talking about, at least with Bitcoin and most other coins, is a Merkle tree, which is a tree of hashes. Is basically what a Merkle tree is.
Kind of just picture a binary tree with hatches at each node.
Yeah, it's very similar to that. I haven't dug too deeply into it because it's down in the weeds. But for any cryptocurrency, they usually have to manually generate a kind of genesis block, which is the first root node of the tree, and then each block is dependent on the previous one. And then the idea is most clients who are trying to figure out what the current network state is, there's only one block in Bitcoin, currently in most other currencies, that is the official current state of the network. There's one block. And usually that block is the one that's the furthest from the genesis block, the furthest in. There's other kinds of block structures out there. There's directed acyclic graphs, but those are kind of in their infancy and no one's really using them yet, beyond a couple projects that have been announced. So each block is a needle in a haystack puzzle that miners, which are these generally super fast computers, try to solve. And the first one to solve it then gets an award, a bounty of Bitcoin or whatever coin it is for finding that cryptographic solution first. And then they're also incentivized as other people send transactions onto the network. Those transactions have a transaction fee, and whoever the miner is that finds that solution first gets to publish the block, and then they also get to include the transactions for people wanting to transfer money around on Bitcoin. They include those in the data payload section of that block as well, and then they can get fees for that.
Does that mean like if I'm starting to break one of those cryptographic puzzles, trying to do the same thing, I get to it first, it's like 90% there, so I have to start all over again.
Yep, he has to start all over. Yeah.
So the miner who breaks the code is the one who records all the transactions for that particular block.
Correct.
Finished block to the rest of the chain, right?
Correct. Yeah.
So if two people solve it roughly simultaneously and publish both onto the network, how does the network determine who did it first and who gets the
That's on the next slide. So
Sorry.
other miners then are incentivized. So remember, it's a peer-to-peer network. So when when miner A cracks the code, then they say, "Hey, everybody, I cracked the code," and then they send out their assertion, basically, that they did it to the peers that they're connected to. Those peers then validate it, and they sign it, and then they get a much smaller, but they also get a fee. The network gives them a reward for signing the transaction. So the idea is, these days, I think it takes about, well, at one point it was like about 100 signatures from other people in the network before it was considered, okay, this really is a valid block. And that's actually a fairly intensive process to verify that as well.
How much is, for breaking the code, how much Bitcoin do those miners get these days?
Initially, it was, I'm not sure what it is right now. At one point, it was like 100 Bitcoin, and then it halves over time. So right now, it's probably like, I think it's 6.7 Bitcoin, or it might be down to 3 something. I'm not sure what it's.
The price it is, that's not necessarily bad.
Well, there's huge energy costs, yeah, and hardware costs, because you can't do it with a regular computer.
Yep.
How will this work when the maximum number of Bitcoin have been created? How
Right.
will you incentivize?
I think that's on this slide. So,
I love this slide.
Bitcoin mining difficulty is designed to increase over time, similar to Moore's law. So about, I think it's every 18 months. Actually, I guess, sorry, the difficulty adjusts with the amount of computational power on the network. So the idea is Bitcoin's goal is to have a block every 10 minutes. So I forget what the sliding window is, but over a certain number of blocks, if all of a sudden people are finding blocks every 5 minutes or every 3 minutes, then it makes there's a way to scale up the difficulty of the computation so that it goes back to a 10-minute average block time. And then also every 210,000 blocks, the actual amount of Bitcoin that's rewarded is halved. So at one point, I think it was like 100, then it was 50, then it was 25, and then on down. So eventually, and I guess I could have shown that graph, it's supposed to go to 0 once the total supply of Bitcoin reaches 21 million. So once that happens, after the mining reward for Bitcoin is 0, the only way miners will make money is by transaction fees. So all the people trying to transfer Bitcoin around on the network will be paying these fees, and then whoever the miner is that solves the puzzle first gets to include all those transactions and gets those fees. Currently, well, part of the issue is, yeah, that's one of the big things with Bitcoin, and that's, I think, a key question of its long-term survivability, is that it's the number of transactions per second right now is less than 10 that the net Bitcoin can handle. And part of that is the block size limits the amount of data and thus the number of transactions. So that's one of the big things right now is there are camps in the Bitcoin community that are trying to scale Bitcoin into thousands of transactions a second or more, but off Bitcoin with some kind of like shim to get it onto the Bitcoin network. And then the miners don't want that because it cuts into their fees. So they're trying to increase the block size of Bitcoin so that instead of only 10 transactions a second, it can do maybe perhaps hundreds or thousands in Bitcoin itself versus trying to use this side chain, this kind of shim solution.
Let me ask you a high-level question.
Sure.
In PayPal, I create an account and I give them my credit card, and then between me and another party, we pass our, PayPal information back and forth. And so my credit card gets charged through PayPal. How's this work with a wallet and spending that $5,600?
Right.
Because I was originally on the conception that you could actually create your own Bitcoin, but it sounds like you're actually more doing a contest of, decrypting it.
Yeah.
Awarded
Bitcoins. Miners will build. I've watched YouTube videos.
Yeah.
These machines are incredible. They make a lot of heat.
Yeah.
You hope to build enough Bitcoin to cover the.
What is the question?
So the
Yeah.
question is, how's the you call it or the system work? Okay, you create a wallet,
Okay.
and in PayPal, my wallet is through PayPal, and they have my credit card information. So when I say pay Humble Bundle,
Oh, okay.
pay A, B, or C, how are they paying the $5,600 per Bitcoin?
Okay. So as far as getting actual dollars,
Yeah.
you have to go through an exchange. So there's an exchange. There's people-to-people exchanges. Like
Now banks.
Banks will start to do it now. But like for instance, I could have two people with smartphones. Excuse me. You could meet and do a cash transaction, right?
Cool.
So I could transfer you the money. You see it comes into your wallet. You give me $100 or whatever for what
Okay.
portion of Bitcoin. So that you can do it person to person. You can do it on an exchange, right? So there's fairly official exchanges out there that are set up to do bank transfers, et cetera. So you bring it kind of similar to PayPal. So you say, okay, transfer, $1,000 from my bank account in. Okay, now buy Bitcoin with that. You can transfer that anywhere in the Bitcoin ecosystem.
And then the other option is you can make your own.
Well, you have to mine it. So you have to be one of those.
That's where you
right.
get the reward system.
Right. That's the only way to make your own is to be a miner and to beat out all the other miners out there,
Yeah,
which is never going to happen for any of us in this room, probably.
once you mine it and you got that Bitcoin,
Yeah.
send it to
Right, and then you have
you. Then you have
the Ponzi part of it.
But big exchange
Everybody keeps adding
is
their names.
one of the big exchanges where you go, you give them a credit card and you can buy some Bitcoin and then move that to other currency, wherever you want to do from wallet to wallet. So that's how most people do it now. They go to Coinbase, they open an account, they give them a credit card or a bank account, and X dollars for this much Bitcoin.
Yeah.
And you're in.
Because it's a limited resource, that's what's driving the price up. Demand.
Yeah.
Thank you.
So as far as I stay away from the whole economic analysis of the ecosystem. I'm sure that we could spend a long time on that, but so far, at least in this presentation, I'm trying to be on the more technical side. Ooh.
The problem makes it hard is the fact that there's no central thing that
Right.
coordinates it. That's the problem.
Mhm.
That's what makes it
But
unusual.
is it really completely decentralized if only a small number of people
Right.
have the computing power to mine?
The miners. That's one of the big issues with Bitcoin is that I think there's less than 10 mining outfits that control over 50% of maybe
Okay.
maybe 70% of the mining power.
So
of
that's like why
Bitcoin.
Ethereum like push really hard to make it.
That's
so you
one of the
can't-
big things, yeah. So going back to your Brian, your question about two miners finding the solution at the same time. So the miner who has better network connection, and better neighbors and or more connected to other miners can propagate their block faster and get those signatures.
So it'll be accepted by the
So it'll be accepted by the network.
Oh wow! So it's not enough to just to have like your ASIC machine. You gotta have like good neighbors.
Right, you have to have good
Fast
connections,
network.
which is one of the challenges for a lot of the big miners in China because they're going through the firewall, the great firewall of China, out to the rest of the world. So, if it's all internal, though, you have to broadcast because if you
get your 100 signature internal.
you could, yeah,
Just
eventually
because
you
most
could.
of them are in China, right? Couldn't they
A
all
lot of the
sign each other's
yeah.
within China?
Just be your own 100 neighbors.
It's a lot of work actually. So you do want to broadcast because it's not as hard as finding a block, but it's significant work that requires an ASIC specialized hardware machine to do that.
Do you even get
So-
control over that stuff, like who your peers are?
You can control who you connect to.
You start 100 nodes, and
Yeah,
do
but
your
then
own-
you're using your hash power to sign stuff versus finding the solution in the first place, potentially.
So you guys are talking about maybe gaining control over the network, maybe?
Yeah.
That's what
I just
Yeah.
meant like, if I need the network to sign mine first, why don't I just build a ton of other
Right.
nodes, in the warehouse next door?
Yeah.
Right.
It costs time. It's not
Yep.
like it's like one
Signing
signature.
for-
No, yeah,
So-
right.
It's competition.
It's probably also one of those situations where I don't know how often, but I mean, the probability of two miners finding the exact same solution at the exact same time is probably really high.
It does happen pretty close
Oh,
though.
really?
Yeah. It actually does
Consider
happen.
the hashes then.
Um,
That should not be
Well,
like,
there-
anywhere near.
I
possible.
haven't looked at it, but I believe that there are multiple solutions. So there's not just one only solution.
Well, it's hashing, so yes, there's the
Right.
by nature of it. What's it called? The pigeonhole principle.
Right.
You can have multiple inputs with the hashing to the same value.
So if you have, I don't know how many possible answers there are, but if let's say you had 10 answers and they're doing a random search through the problem space,
Yeah, but
then
the fact that they exist is one thing. The fact what's the probability of the two of them
Right.
existing, and then what's the probability
Yeah.
of that they would be close to one another, that
Right.
where actually milliseconds start to count.
well,
So you
yeah.
just made the probability go from really bad to not possible, really.
Yeah.
I mean,
But there is a
Yeah,
chance.
is that the question here?
It can
people that
take
do lottery.
I think usually it takes an hour, I think, or two before people consider a block finalized.
So isn't there a significant
So-
amount of time for someone to try to get in there and, if you solve it within a few minutes, would you have a chance of
Right.
yours being the one that gets signed? 6
Um,
hours?
So what if your competition controls most of the 100 nodes that you're trying to?
Well, they could
sign with?
potentially-
Yeah, it was
right.
Couldn't they basically just
Yep.
sort of black hole you?
They could do that, or they could slow down the propagation of your stuff potentially. So yeah, you want to have a if you're a Bitcoin miner,
what
you want to have
incentive do they have to do it?
you want to be as
well?
connected as possible because they get a fee. The people that verify the block that you found also
Yeah,
get a
but
fee.
What if there's an imbalance and they find the right ratio of how many do we need to screw over you?
Yeah. Oh,
And then we can,
Yeah.
well, yes, we sink some money into screwing you over, but we still make more.
yeah.
from
There's
screwing you over as
there-
opposed
there's
to
definitely
ourselves mining.
some shenanigans
There's gotta
on
be a
that level
balance.
in the network. For instance, one of the things you can do is if you find a block, let's say within a minute, right, or two, you could actually delay publishing it because each block is the seed for calculating the next block. So if I find a block in like a minute, I'll be like, whoa, I'm going to hold on to this for 2 or 3 minutes and give myself a head start
Oh,
calculating
you
the
start
next
calculating
one,
the next one.
and then I'll publish that first one. But that's risky because now somebody
Someone
else
gets
could.
it.
Again, with the
So-
probability of someone else finding, again, 2 hashes in a row, one dependent on one another.
Right. That's
in the same, even shorter time space.
Yeah. All right. So anyway, there's lots of crazy behavior and interesting stuff going on. So far, the network's held up. One of the things people are always curious about is security with Bitcoin. Right now, the Bitcoin network actually is over 80 billion as of today. It probably went up to like 90 years or more.
Yeah, I think it's more than that. I thought it was 130 billion.
That's total.
Yeah, I think that's total crypto market. Just Bitcoin itself is only 80 or 90. So one of the behaviors that is known is if one of the miners or a group of miners colludes that has over 51% of the mining power, then they could potentially double spend. So you could mine 2 chains, and you could say, hey, I'll give you $10, and then set up the way that you distribute your blocks such that you actually give that $10 to somebody else. But that's only possible if a group of miners controls at least 51% of the network hash rate power. So far, no one's ever seen that attack happen.
Except for cryptocurrencies similar to Litecoin back in 2014. They suffered a 51% attack. But
Yeah.
moving on to the next point is the reason why it can't happen.
Right. So when people talk about the security of a network or a cryptocurrency, it's for currencies that are vulnerable to 51% attacks. That's the shorthand. It's how much would it cost to get 51% of the computing power in the network. And for Bitcoin, it would be about $2.3 billion in hardware that you'd have to get in order to try to.
That's a good investment right
Yeah, but part of it.
Bill Gates.
Part of it.
That's within the reach of
Right.
like a government.
Right, a government.
The
So
problem is
yeah,
that you have to maintain it somewhere, power costs.
Yeah. But I mean, the
Just bring up
government
who's
again,
gonna
right?
maintain it.
Government.
That's
Yeah.
assuming
Just
you
bring
can
up
buy
who's gonna maintain it.
Yeah,
$1
but,
billion worth of hardware
Hire-
front right away.
That's what's legit.
but
Hire a
isn't,
big
Narrows
100,000
down
people. Yeah, so now.
but
Yeah.
isn't there now, is it Pirate Bay, or when you go
Yeah.
visit them, they're actually using every browser's computer
Right.
to do data mining.
But that's still not. It's
2.3
still
billion.
Yeah, I know. But
ASICs can do. So it's
Yeah,
very
founders.
it's ASIC machines that do crazy amounts of processing power. So it's because initially Bitcoin you could mine it on a CPU on your computer. Then CPUs were too slow because they figured out how to parallelize it onto graphic cards with
right,
GPUs. And then it went another 10 to 100 times more powerful with ASICs when they figured that out. So at that point, now ASICs are just blowing away everything else. So that while you can, distribute Bitcoin mining is like a background process on web pages that different people load. The only reason that works is because you're not paying the energy costs for that. But you're not. I don't think you can really take over the. I would be very surprised if you could do a 51% attack just off of a background process in people's web browsers.
but if you're using like a Tor network, which
Yeah.
Well, you have that ridiculous photo.
Yeah. So so how it works, right? So all these, so it's a bunch of interconnected nodes. Clients are nodes that I'll have to download on Bitcoin anyway, the entire history of all blocks in the Bitcoin network. There are some shortcuts you can try to use. So if you have a client that doesn't make you a miner, that just means that you can send and receive Bitcoin blocks along with and retransmit those to your peers as they come through the network.
By client, I mean just someone with a wallet.
Right.
A wallet that holds their.
Yeah, I mean you can in order to you can hold a wallet. You can have a wallet without having a client software, but you can't send transactions without a client. So you can receive money to your wallet passively. You don't need anything to receive once you have generated a wallet address. But if you actually want to send Bitcoin to someone, then you need to go through a client to send that to transmit that transaction onto the network.
Are there like Like, I don't want to.
So that has
Yeah,
to-
there are like RPC services and like websites where you can put in your private key, which is kind of scary. And then you say, okay, I want to, and then they say, okay, on the web page, you'll say, you put in your private key in there, and they'll say, oh, you've got this balance. And then you say, send, 5 Bitcoin to this balance, to this wallet.
So who's the consortium? You were talking about them, or the ability to up and down the rate and make it harder to mine. So, but there's no centralized repository.
Right.
So who's the organization?
So there's consensus rules that are baked into the clients that the miners are using, that everybody's using, that just says, okay, a valid block has this definition. And then a valid block depends on the last, there's certain rules that take effect by looking at the past n number of blocks in a particular window, like let's say the last 1,000 blocks or whatever.
Well, we don't have like an Apache who's saying this is what, Tomcat
Right.
is going to look like. A centralized repository.
Right. Here's what's great though. There is a centralized repository. People are using, there's a main Bitcoin client software and project that's kind of the keeper so far. But there have been other fork attempts, and there's actually actual totally new bits that are out there. But so far, the main Bitcoin has been fairly just that one organization still. I think it's Bitcoin Core or something. I've forgotten who it is these days. And so, yeah, all the rules of the network are basically enforced by the software. So if one person tries to fudge the rules, they'll generate blocks that are invalid that nobody else will accept.
Okay.
And thus, that's what. So there's no economic incentive for me to fudge the rules if I'm the only one who's trying to fudge the rules, and the network will catch it when I try to pass those blocks on to other people.
Okay.
So that's the consensus rules of the network. So yeah, right now, for full clients, you need to have the full transaction history, all the blocks that have ever been mined for Bitcoin, which right now is 130 gig, I think, for of data. You can have a light client implementation where you have some subset, like if you again use some, you have a trusted node that you connect through to get the state, to kind of proxy the state of the network to you. But this is one thing that makes it hard to run like full Bitcoin nodes on like your cell phone, right? Because you're not going to be able to have 130 gig. Well, you might. So Bitcoin was the first one. It was around for a relatively long time on its own. Litecoin was the second one that came out. It was designed to be resistant to the super fast ASIC mining chips, which were responsible for like centralizing a lot of the Bitcoin network power with a much smaller number of people that had full data centers and had geothermal power, or were getting power for free in China by like tapping lines or something. Basically, that's what kind of happened. So there was this huge centralization, which is less of a problem, but still a problem with Bitcoin. Litecoin was created as kind of a response to that because they wanted to kind of give the power back to the people by making a mining algorithm that was resistant to these super fast chips that would pretty much only run in large data centers. It also tried to bring the block time down from 10 minutes down to 2.5 minutes. So you could have so your network state could move forward more quickly. Then Dogecoin, I believe, was the third major one created. There may have been a couple other ones, but that's the one people know about. And that was supposed to be like a satirical kind of take on the whole thing that actually, for some reason, blew up and got wildly popular. And it's pretty much been slowly dying ever since. And then there's been many other, they're called altcoins or alternative coins, created since then, like I said, over 1,000. with small and large improvements to all facets of what Bitcoin is.
So maybe someone wake up and say, you know what, I'm going to create a digital currency today.
Well,
Yeah. Like beer coin, like there's one specifically dedicated to like sharing
Yeah.
drinks with people.
there's there is a libertarian kind of community that thinks that this is going to take over and get rid of the banksters, you know, the fraudulent bankers. Yeah, but it's pretty much obviously not happening. So there's that kind of romantic appeal to it. There's also, especially, I mean, over the last couple of years, the whole get rich quick thing, right? People are thinking, oh, if I just do anything in the blockchain, I'm going to be able to retire. There's lots of it's similar to the way the internet was in like 98, maybe 1998. Right, and there's potentially a lot of room for to become the next Google, right? In the space, so there's still a lot of room for innovation. It's still very young. We don't really know what it's going to look like in another 10 years. You know, I mean, it's kind of like Google in 2001, maybe 2000 even. Like barely out there. We kind of can see what it's doing, but so the natural evolution of this, and I admit to being biased to this particular altcoin, Ethereum, I believe, is probably the next major step in cryptocurrencies. So it moved from from Bitcoin's 10-minute blocks and Litecoin's 2.5-minute blocks down to 15-second blocks. Right now, it's slower than this. It's probably like it might be up to a minute at the moment, but that should go back to about 15 seconds or thereabouts. It supports right now about 15 transactions a second. The big thing that it has that nothing else before it had was it says a Turing-complete scripting language built into it. And the language, the execution of these scripts can be verified on the network. So basically, you can write a program and prove that the operation of the program was exactly as written in the contract, in the smart contract. And I'll get more into that. Right now, it has the largest share of commercial companies and new blockchain development. Pretty much everybody was trying to do new, distributed, trustless, safe logic on Bitcoin ever since it came out. And pretty much it hasn't been possible because it doesn't have a scripting language. There's no way, so far no one's been able to really do anything like this anyway. One of the things that Ethereum has is these ERC20 tokens, or the standard for smart contracts. And this makes it way easier for someone to create a new alternative currency, right? Like beer coin or whatever. Because up until now, if you wanted to create a cryptocurrency, you had to create the mining software and all the socket code and the peer-to-peer logic and the consensus model to distribute that logic across all these nodes across the world. Well, with Ethereum, they said, okay, we'll take care of all of that bootstrapping for you. All you have to do is define your new coin in a particular kind of smart contract and publish it out there, and bam, you can have your own alternative currency with the safety of running on an established network already.
You know, if you still need to have the community or the support around that new coin you create, or is it all leveraged based on the Ethereum sort of framework?
It pretty much all leveraged on the Ethereum network framework, yeah. So I mean, that doesn't mean it'll have any value or anyone will use it, but as far as an actual coin, it's pretty simple. It's less than.
You just have to mine it, right?
Nope, you don't have to mine it.
They can just straight buy it.
Now you have to choose your distribution model. You could make some. So most of these coins are not don't have a mining paradigm to them. So they either, when they first create it, they say. So far, the model has been that someone says, okay, I'm going to create Beercoin, and we're going to have our initial public offering, right? Kind of similar to a stock sale. ICO, right? And they say, okay, we're going to, when we create this coin, it's going to have a total of 20 million coins, and you can verify that. There's a cap. There doesn't have to be a cap, but usually there is. And then they say, okay, you know, there's a function on this contract that manages the coin where you can send Ethereum, and then it sends you the coins back at whatever the exchange rate is. So you call a function on the contract and say, you know, buy token X, and and you send it 10 Ethereum, it sends you the response. So anyway, to keep going, one of the big problems with most cryptocurrencies is they don't have any conception of data outside of their crypto network, right? So Bitcoin doesn't know who won the election. It doesn't know who won a fight, you know, like a boxing fight, right? It doesn't know what the weather was yesterday. You can't just do an HTTP call in a trustless manner on the Bitcoin network. So it doesn't know about all of its guarantees. Don't apply when the information is outside the network. That's true for almost basically any coin. Bitcoin doesn't really have a reason to have this, but because of smart contracts in Ethereum, we have this idea of oracles. So there are these services that are designed to bring in that outside data so that your on-chain, your smart contracts can work on it, right?
How do you become an oracle? Can you just make one?
So it's the main point of Ethereum is trustless, right? So the idea is I want to be able to verify the source code, verify the information, and I don't have to trust a particular party to act in good faith because I can just trust that the network will work properly. So with an oracle, it's a very trusted position because now you're the intermediary between someone's contract, their script, their code, and the outside world. Mm-hmm. So like Oracle Lies is one service, and they've been around for a good long time, and so they've built up a reputation. Mm-hmm. So you basically give them, you can set up an oracle with them, and you say, okay, you know, you look at this URL, process it a certain way, and then put this information on the blockchain under a particular kind of address on the Ethereum network. And then you can write your smart contract to say, go get that information and
what costs me?
You pay a transaction fee to the Oracle service. Mm-hmm. So their business model is to be honest, because if they aren't, then as soon as somebody sees that they're cheating, they will stop using them, and their whole business will fall apart. Yeah. So, but there's no easy way to verify trustlessly on the Ethereum network that the Oracle isn't lying. Mm-hmm. So
the fact that it costs you money to do that, I guess that when
right.
outside of that, it's free, usually, or can be for certain
right.
services.
So that's the other thing is because it's trusted, it's not cheap necessarily. To do any heavy lifting computation, you do not want to generally do that on any blockchain network right now. And I kind of get into some of those.
A lot of these like oracles and other sources most of them are all open source too, right? Mm-hmm. Hopefully have people
right
going through their code and stuff.
Yeah, their source code.
So
but you're still trusting them.
I'm sure that I can still trust them, but the fact that it might cost me something to like go and use their service though, but
yeah.
But I said they write the results into the block for the Ethereum.
Yes.
They know something, and then once they know something, they say, "Oh, here's the result."
Well, usually you have to call them and ask for it, kind of thing. So your contract says, "Hey, Oracle, what's the who won the election last night or whatever,"
Gotcha.
And then it makes the query, brings it back in either that block or the next block. And then it makes that information available to you in some form.
So it's just like a Boolean value or something? Like
it could be a string, a number, pretty much anything.
How many of those are there now? How many oracles right?
I mean, you can go to their website and define any random. It's basically, think of it as the intermediary between you and the rest of the internet, between Ethereum and the rest of the
I
internet.
mean, but there must be a bunch of different ones. There must be thousands or hundreds or.
There's Ethereum has one main one. There may be 2 or 3 other ones, but it's one Oracle service, and you go into their website online, and you can define a new Oracle for you to use from inside the Ethereum network.
Is this something that in the contract the parties agree upon what Oracle we use and like what the?
You could do it. You could do some kind of agreement voting or consensus method. Usually, it's just hard coded. So,
Has anyone looked into a decentralized Oracle system?
there's a couple big projects working on that right now that claim to be going that route. I'm not convinced yet how possible it is, but it's, yeah, they're working that way. Yeah, well, that's so other big things that Ethereum can do right now. It has other consensus mechanisms already. So with Bitcoin and most cryptocurrencies, I just talked about, there's this cryptographic challenge that you have to mine and you have to find the solution. There are other consensus models that you can use that Ethereum actually supports right now. So for instance, if you want a now, not publicly, but privately, right? So let's say you want to run a private Ethereum network, right? Inside, like NASA could run its own Ethereum network. You could potentially do it based on proof of identity, using like cryptographic keys that each. So you could have a set number of nodes that are allowed to run on the network, and you identify them via the cryptographic keys. And they are allowed to publish and nobody else is. In that situation, you don't have to have this super intensive cryptographic challenge situation. All you need to do is verify the signatures servers in the network.
That's more permissioned.
Right, that's a permissioned blockchain versus.
Verifying signatures is part of the
Sorry.
crypto operation, but you're not getting away from it.
Right, but you're not mining a especially hard cryptographic problem though that would take you 10 minutes on an ASIC machine. Right, it's just signing it. It's like it's as hard or fast as like SSL basically. It's just straight up SSL at that point.
So now in order to fake it, you have to compromise all the.
Right. You would have to either steal the private key or break like SSL or something. Right. So there are test networks or private networks that can use. Just basically proof of identity, right? I've got this encryption key, I can prove it, therefore I can publish blocks on the network. So with that kind of situation, you don't have super energy intensity, you can have super high transaction rates. That's not a trustless system. That's because you're controlling or you trust all the nodes in the system. So that's possible as a private network. I think there's a couple public but test networks for Ethereum like Coven and Ropsten that use a couple of these other consensus algorithm schemes. So smart contracts, right? You guys want to know what you can actually do with Ethereum besides retire in a couple of years, right? So. So yeah, sadly, like I said, I was trying to focus on the technical and use cases versus just, here's how you retire in a couple of years. So here's one example, right? Let's say you want to do a smart contract and you want to do matching donations, right? So a charity could set up an Ethereum wallet, and then a wealthy contributor makes a smart contract and sends it Ethereum, right? The contract can actually control Ethereum on its own. And you can write the contract in such a way that the person creating the contract actually can't access the Ethereum that's stored within it directly. They can't directly control it. Now, what you could do is you could have the contract check the balance of the charity wallet, and if it gets to a certain amount, then the Ethereum in the contract is also given to that charity, right? And you could verify the source code. And then you could say if that amount, if the charity didn't make the minimum amount of donations, then the contract will send its Ethereum back to the original wallet of the contributor. So again, this isn't necessarily the most exciting application, but this is one application of a potential trustless system where people could validate the source code of the contract, which for something like this would be actually fairly small, like maybe under 75 lines, maybe under 100 lines of code for something like this. And then verify that, okay, they actually have the funds. It's not some kind of, trick or scam. But I mean, with donations, that's not usually a huge problem. And then this is, I got this idea from Dan Mandel in his talk earlier. I don't know, a month or two ago.
September 13th.
Yeah. What about using something like this for TDRS scheduling? So if you assumed that each TDRS satellite and the ground stations were nodes in some kind of private Ethereum-like network, you could publish schedules of contacts and then let it propagate between the satellites. I'm not even sure if that's possible if they propagate between them. But,
well, I mean, that's the whole thing. I mean, in new networks and new way of doing things, everything will be connected at some point.
Right.
I don't know when, but they're trying to work on that.
So the schedules would propagate to the satellites, and then as the satellites process contacts, right, there's status information back to the block to say, okay, I handled this block. It took this long with this average data rate, something like that.
What you've got here is a decentralized scheduling model versus a centralized scheduling model. And can you be more efficient? That's the question. Can it be more efficient model?
So you could combine this with some kind of like AI or some other
your Oracle
system.
Oracles would have some AI services that somehow put things in there and manage. But that was my thought.
Yeah, so that's possible. Obviously, this is a really high level view, but something like that might be possible. Again, you would probably want to be careful because of the size of data, the amount of chain data stored on the satellites, because I'm sure the data's at a premium. But you could do some kind of light client thing where they only have the last 5 or 10 or whatever 100 blocks of the network.
That's the same problem with all flight software.
Yeah.
They have to be light.
Yeah. So. But that's another possible thing. One of the big ones that's talked about a lot is voting, right? Because everyone's scared of, rightly or wrongly, about voting fraud. So one way you could do it is if everybody has a wallet, you could then sign a free transaction, putting your vote into a smart contract, and then the smart contract can tally the votes. So, or in this case,
what's stopping me from getting 15 wallets?
15 wallets. Though so I guess I should have started from the beginning. So, a smart contract is created, let's say, for ownership in a company, right? And the company has 100 shares. So the idea is each owner's wallet, they are distributed, they are given one share sent to their Ethereum wallet, and then owners can then use their wallets to place votes on, let's say, on proposals by calling like a vote function on the smart contract. And because it's coming from, because we can prove cryptographically that it came from their wallet, which has one share, we can say, oh, tally one vote for X client. And then you can also, assuming you do your bookkeeping correctly inside the smart contract, you can keep people from double voting.
So if you want to do this at like a national level, you
You're
have
not
to
proving
decide.
people, you're proving number of wallets.
Well, there's a solution
Right.
some blockchain techs are introducing called digital identity.
Right.
So now you have the concept of an address tied to a specific identity. You validate that identity.
What's stopping me from gaining multiple identities?
You-
I'll keep repeating this question because there is no
I'm
good solution.
explaining
Right.
to you the answer to this question.
Well,
don't think it
identity is
exists.
not
It
right.
does.
Identity
It
is a non-chain thing.
Yes.
So yeah, all the problems with real world identity carry over to identity on a blockchain.
Therefore, it's not fixable.
Right? It's not right. You're right. Yep.
Right.
So-
the thing is, it still can be done in a trustless manner, because you can basically have a smart contract validate that identity.
So what we can prove is that a single identity did not vote twice,
Yes.
or voted a particular way.
Or vote at all.
We can't prove that the identity is valid or that you don't have 100 identities. We can't prove that, but we can prove that a single identity didn't vote twice and it voted a certain way. So you could go on to the network and say, I don't know, I'm feeling a little suspicious. I wonder if they recorded my vote properly. You could actually go onto the blockchain and verify that your vote tallied under the correct column. So,
Is there any way to protect anonymity from other people?
Right, so
what if
that's-
my family's really mad about how I voted.
right.
You
So
have-
you can, that's one of the things actually, tomorrow, I think there's going to be a huge network upgrade on Ethereum, and it's going to use elliptical curve to cryptography, which should let you vote anonymously.
Okay, as long as someone else doesn't have your key, right?
Right.
But something
Well, yes, but
Um,
you got a lot of problems.
Yeah, if that happens, then all bets are off.
Well, yeah, exactly. So I'm just saying that's,
So,
that's
right.
incredibly unlikely.
Someone has your private key, I would assume.
Unless you gave it to them.
Right.
Probably not.
Or if someone has a quantum computer that breaks the
Yes,
algorithm.
exactly.
That's one of the things too. The next Ethereum update allows them to switch their encryption model that's backing the system, so that there already is one in that they know about that's been implemented that should be quantum safe. Now that's one of the things, so that you can choose what encryption schemes you're using to back up your transactions. Now that's not deployed yet, but in the next week that should be the case. So if all of a sudden next week Google or somebody says, hey, we've got 1,000 qubit thing and we've just cracked RSA 4096, right? Then in 10 minutes, then pretty quickly you're going to see Ethereum's going to say, yep, okay, everybody switch over to this other algorithm. And that's one of the problems with Bitcoin is it's not so easy. So they would have to release a wholesale. Yeah, there would be there would be blood in the water if that happened with Bitcoin. So yeah, identity registrar. You have somebody like NASA could be an identity registrar for NASA identities. Google, they could release a token that's tied to you. And then you can, these identity tokens, kind of like what we were talking about earlier. One of the big things is for financial transactions, they have all these exchanges and banks need to know your customer because they don't want money laundering. So they need to know your name, have a picture of your driver's license or passport or whatever.
All these altcoins is to they're transferring money, so banks exactly don't do that.
It's not particularly anonymous.
Well, all transactions are trackable on most networks. Zcash and probably soon Ethereum will be able to have anonymous, truly anonymous transactions on the network. But there are things, for instance, what if I want to get a loan, right? Let's say eventually banks go on the Ethereum network, right? If I want to get a loan, they're not going to be happy with, hey, I'm Anon user 123 and I'd like $100,000 for my house, right? So you will need, some point, you will need to prove your identity, be able, and again, this is to be able to prove your identity or have some kind of trusted identity token that you can use when you want to, when you need to, at a minimum, right? So if a bank's on, I want to get a loan, and there's a bank that's on the Ethereum network, I could have some kind of token, for instance, backed by Google, that's tied to my identity. And I could have multiple levels of information this token would potentially release to someone I give it to, right? So I could say, it could be just my name. It could be my name and my address. It could be my name, address, phone number, security answers, right? You could have multiple levels of information, and then you would send that token to whoever you wanted to do business with. And then that, since you signed that transaction to them, that would unlock the information for them to get automatically versus filling in that same website information with those 20 fields over and over.
Already with as much of crypto. How's it different?
Yes, but this could be a formalized method for taking action on it as well. So again, it's not that it's never been done before. It's that if you wrap it up and make it along with the rest of the ecosystem, it could unlock a lot of really cool things potentially.
Also,
So it's not here yet.
Also, if business was looking to implement this for someone, yes, they can go with the traditional solution, or they can decide to use the blockchain because the tech is just ready there for them. Easy to implement.
So a lot of the new crypto coins out there are trying to implement particular features. So they're trying to do like global lending, like helping people, loans for small business people across the world, right? There's this whole banking the unbanked in third world countries like India.
Can you talk about banking real quick?
Sure.
So are you familiar with Ripple?
Oh, yeah.
So they're at about a quarter a coin right now.
Yeah.
So their thing is they pre-mine them. It's like 155 billion coins, but they only release 38 billion to the market or something, and then the others are held in reserve. So, with the understanding that that's going to help banks transact, do these transactions quickly, how is that going to benefit a user who invests in that or something like that when they could just release 40 billion to the market and flood the market and go with that?
Right, I agree. I think I'm personally, I'm probably understating it when I say I'm not very excited about Ripple, largely because of those reasons. But there are other currencies out there, for instance, that they're developing, like an app where, if all you have is a smartphone and you're in some third world country, and every once in a while you get into Wi-Fi range, right? You could potentially, if you get a system where you're able to barter with other people just by transferring some kind of e-currency, right? Now you don't have to worry about carrying cash. You don't need a bank, so to speak. You could potentially show like a transaction history to somebody by looking at the blockchain. So you could potentially get loans because now you're showing, hey, I transferred X amount of cash around from selling whatever I'm selling or doing whatever services. So yeah, I don't think Ripple's an international, they're trying to be the next SWIFT, bank transfer system. They're not really trying to help, especially like the unbanked people in the third world. But yeah, there's at least 3 or 4 other ones out there trying to actually reach, not being an interbank system, but kind of being a peer-to-peer banking system for people in the third world.
So I guess, so is it true then, like, for example, like things like Ethereum where you don't have the money because it doesn't cost resources, right? So if you come up with a new coin, shouldn't you just make the coin value be static? Like you said, to have 20 million coins, each one worth $1. Wouldn't that makes more sense? Because then whatever you're building the coin for, whatever platform, say buying beers, right? You say, okay, if you want to buy beers, use this. It's kind of worth $1. It's easy. Once you have it, just press a button.
Yeah, there are ways.
Why do you have to, right? Why do people have, just like Bitcoin right now? It's crazy to think like 6,000, you could go up to 10,000, whatever.
Or it can crash.
Right.
Because
Right. Well, if you own Bitcoin and you're invested in it, you kind of like that it goes up, probably.
Well, no, that's
I mean, you want it to go to 10,000.
But then it becomes a self-fulfilling prophecy.
Right.
Yeah, but
It's an ecosystem.
But-
Right.
And the ecosystem grows by some motivation. Their
No, but-
employee motivation.
But for
Yeah.
instance,
What I
Russia,
understand is
It's mostly speculation.
Yeah,
Oh, that's
it's
it.
not
Which
really-
I guess
Right.
you could design a coin which has a market behavior like a 401k pretty much, right? Where just like
Well, which they've
No.
tried to do, which they've tried to
which
do.
a lot of people are trying to do.
The challenge with trying to have they're called stable coins. So trying to have a stable coin where it's tied to a particular value and it just sticks to that value is you have to have some mechanism for overcoming speculation and supply and demand issues, right? So usually the easy, dumb answer is usually they have it backed by other assets. So they have an audit and they say, okay, we've got 1 million of these $1 coins, and we have an audit showing from our bank that we've got $1 million in the bank, and so we can prove we have these assets that somehow intangibly back these coin assets that we've done. Or some places will do like gold bullion and some fancy vault somewhere, and they've got individual serial numbers stamped into them, and they've got
It's just like gold-backed paper money. That's
Right,
been around for
basically,
100
right.
years.
So there's stuff like that.
Right, yeah.
So there's stuff like that out there already. One of the issues is it's not trustless, right? You have to trust them that they did the audit properly, and their bank or whoever that is isn't lying to you as well. Which is, if it's a big enough bank, that's probably a fairly safe bet. But if the ecosystem gets really huge, and we're talking about like $30 billion or $60 billion worth of assets, right? Now it becomes harder and harder for them to have that escrow system backing the value of their coins once it gets to any real size. With a stable
Like,
coin,
for example, like who's backing up Bitcoin right now?
so nobody is, right? But
if you want to get down to it, what backs up anything?
Right, what
Just
backs up
people
the-
think it's worth.
The
What-
U.S. Well, for example, the dollar is backed up by.
Right.
Actually, but
the
that's not
actual-
true.
The actual value of the dollar is only based on because we think the full faith and credit of the U.S. government is
Right,
worth
that's right.
something. And
Yeah.
tomorrow we all decide it's not worth anything.
Once the
paper
dollar
in your power is
converted
worth
from the
nothing.
gold standard. then
But
you-
Right.
you can even take it back another level. Why is gold worth it? Because someone
Right.
says it is. Tomorrow we're all
Yeah,
like,
because
"We want
something
that."
with
a dollar.
Gold has an intrinsic value too.
Nothing has intrinsic value. It's only worth what people
Right.
are willing to pay for it.
but it also is limited resource
Limited
as well.
Right.
Yes.
And that's one of the things
But
with
so is-
Bitcoin is there's only 21 million of them eventually, not yet
No,
even.
as long as you have some
Not
utility,
150, yeah,
utility.
84 billion of them.
Utilities how
Yeah,
to manage value.
Right.
It manages value.
I mean, there are a limited number of 68 Mustangs out there, but if everyone decides tomorrow that they don't care about vintage cars, the price will crash. Nothing really has intrinsic
Right.
value. It's just what people think it's worth. I mean,
I probably should have looked it up, but there's those three things that make money, right? It's was it fungibility, scarcity, and I can never remember the third one. But basically, Bitcoin and most e-currencies have those things, and so to whatever level the economics is kicking in is whatever the the value that's ascribed to them.
Yeah, but twice Bitcoin almost went under what, $1,000 when, let's see, Russia said.
Yeah, China.
And then China, or was it right? So I was surprised when you said $5,600 because,
It went down. It went,
Yeah.
The
it
volatility is
crashed last month
unbelievable.
because of China.
and then
So-
Russia was one before it.
So anyway, to have mercy on anyone trying to listen on YouTube and us, hopefully. So final thoughts. Yeah, storing data on the blockchain is expensive. So you can use it to keep the current state of something if that current state is not a whole lot of data. But if you're trying to talk about like storing even hundreds of kilobytes of data on the blockchain is fairly expensive compared to traditional computing stuff. So, I mean, if you're talking about trying to store megabytes or gigabytes of data, it's not really there right now as far as public blockchains. Now, again, if you want to do some private Ethereum network kind of thing, you could probably make that work fairly well. But as far as public stuff, it's going to be pretty hard to do. There's some efforts underway for like an Ethereum or other backed peer-to-peer file systems like Ethereum Swarm, Filecoin, ShiaCoin. There's a couple other ones. that are trying to solve that problem. I think Filecoin and Shiacoin are already out. I'm not sure how exciting they are. Ethereum Swarm is pretty sweet because it's going to be it's not yet there, but the plan is to integrate this into smart contract logic, so your smart contracts can actually grab files from like a file system basically and take some action. So that's still in its infancy. Yeah, so there's limited on-network data, right? We don't know what the weather is. We can't just grab. Ethereum network needs oracles to get anything off the wider internet that would be out there. So it doesn't know who won an election, you know, the exchange rate for, you know, corn or something like that. All those kinds of things. It needs a oracle to provide that kind of information. Transaction speeds are severely limited versus our, you know, computing today. You know, like Bitcoin's 10 minutes, Litecoin's 2.5 minutes, Ethereum's 15 seconds. There's some new tech coming down the line for Ethereum that will probably allow them to get thousands of transactions a second and potentially have a block every, I think they're going for like 3 to 5 seconds eventually. But again, that's not quite here yet. Yeah, so basically sharding, plasma, Bitcoin's trying to do the Lightning Network, but that hasn't launched yet. That's supposed to try to give Bitcoin hundreds or thousands of transactions a second. The rest of those are Ethereum things. So that's pretty much it.
Good, very good.
So, yeah.
Can I get a copy?
Sure.
There's,
I can email it to you too if that's.
oh yeah, yeah, maybe. Yeah, also, I'd like to talk to you sometime.
Can you just put in the slide, the
Put it on the
GSFC
website.
developers?
Yeah, I can hear. I'm gonna get my laptop actually.
Yeah. Well, which building are you in?
Yeah.
Are you in this building?
I'm in building 32.
Okay, yeah, I like to talk to someone, 'cause I gotta come up with some ideas and
Yeah.
you've got some. More than I do.